welcome to a new episode of Mostly Engineering and another part in our Enigma builds. So, welcome to this episode, and today we are going to manufacture the lever that pushes our reflector drum forwards and therefore ensures that we have pressure on the connections and therefore ensures that we have an electrical connection. And that's this part over here. And the original plan calls for the main body of the lever to be made as one piece, but this is first complicated, second wasteful, so we are not going to do this. Instead, I divided it in 4 parts. So we'll have the main body machined out of 2mm aluminum, and then we put a 90-degree band in it, and then we will have the 2 pins that actually pushes our reflector forward. That just simply screws to the plate, and here we have the ends are rounded. So for the first time I will do some ball turning on the lathe, so let's see how this works. And last but not least, in the center we will have the bushing that our lever can ride on the shaft, and to ensure that it goes really nice and smoothly, we will do this out of bearing bronze. And unfortunately, bearing bronze has the wrong color, so we will do some electroplating as well. So as you see, lots of new things to discover, and with no further ado, let's go over to the CNC and start manufacturing. So, and yeah, that happened. And bending aluminum around a sharp corner is actually way trickier than I was thinking. And I talked with my colleagues about it, and they all said, like, yeah, aluminum is not the right choice for this. So what I'm doing, taking blah, 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 blah. So yeah, that happened, and yeah, bending aluminum around a 90-degree turn is actually way harder than you think, and what we achieved is around 45 degrees and not the desired 90s. And I talked with my colleagues about it for tips on how to bending aluminum. They all said, yeah, aluminum is not the right material for this, at least with the manufacturing capabilities we have in the workshop. Brass will be the way to go, because brass we can heat up and it gets nice and soft, and then we can bend it, and brass is work hardening, so while we are bending it, it gets hard again. And the added benefit of brass is that we can do then the pins out of brass as well, and the brass and the bearing bronze bushing will then solder very nicely to the brass plate, and this is a much more secure connection than screwing it in, or in case of the bushing, gluing it into with 2 pins. So let's redo this part in brass. The only disadvantage is that I don't have 2mm brass, I only have 1.5mm lying around, but I think this 0.5 millimeter won't make that much of a difference. So back to the CNC again. So, and here we have our finished lever, and it came out really nicely. Now, as you can see, soldering relatively straightforward. You put the parts in, and I coated it with some solder paste before, and then just apply the heat. Make sure that all the parts are heated properly, and then you put in a little bit of solder, and with the flame you can guide it around your part, because solder always flows to the hottest spot. Now, the two brass pins worked absolutely flawless. The bushing made out of bearing bronze lifted slightly, because I think the brass and the bearing bronze expand slightly differently at heat, and so it got pushed away a little bit. But I'm not even sure if you can see the small gap, and I don't think it's going to matter. And then the electroplating, as you saw, or in this case nickel plating. And nickel plating is very forgiving. It's more or less like brushing on the metal. The only thing you have to keep in mind there is wear respirator gloves and so on, because this kind of stuff is not really a spa treatment, to be honest. And then your surface needs to be absolutely clean, and you need to prepare the surface to the finish you want after the plating process, because electroplating will hide absolutely nothing. And you still can, on the backside you see it better, you can still see some of the solder blobs. You still, in the right light, can see some of the sanding traces there. And yeah, it will hide absolutely nothing. For a machine that is supposed to be 90 years old, this is really nice. But if you want mirror finish, for example, you have to put a lot more work into it. And the process itself is really simple. You put one electrode to the part, and the other one we have the sponge thing, and you dip it into your electrolyte, and then you just brush it on. And on your electrical side, you choose a voltage that you have a little bit of current flow. So in this case it was about 3.3 volts. Worked absolutely fine, so that you get a current of 0.1, 0.23, something like this amps. Because if you go too high, above 0.5, something like this, you risk that your metal gets actually black, and you probably don't want that. So, but with this done, it's now time to mount it to the machine and see if it works. So, and everything is mounted now, and when we push the lever down, our flagler drum moves forward. Very nice. And yeah, let's do it again. Of course, at this point, the lever just falls through after a point, because all the mechanics behind here are still messing. But for now, that's really nice. And on this note, it's time to end the show. So I hope you enjoyed it. If you have questions, comments, as always, let them down below, and I try to answer them as quickly and correctly as possible. Don't forget to like and subscribe. And all that's left to say now is thanks for watching, and see you at the next time. Bye bye.